So here are our trigonometric ratios. It's 8.4. The ratio of the length of two sides of a right triangle is called a trigonometric ratio. Trigonometric ratio. The three most common ratios are sine, cosine, and tangent. And we abbreviate those as sin, cos, and tan. And so if we look at this, if we look at this triangle here, sine of A is equal to the opposite leg, so the leg that's opposite the angle, over the hypotenuse, which is the side that is opposite the right angle, C. So it would be A over C. And so sine of B would be, this is the angle B, it'd be opposite. Now the opposite changes. The opposite here would be AC over the hypotenuse, which is C, so it'd be B over C. And cosine of A or B and tangent of A or B, it kind of works the same way, except now here with cosine we have the adjacent leg over the hypotenuse. So for cosine of angle A is here. So the adjacent leg wouldn't be this one. This is the hypotenuse. The adjacent leg would be this side of the triangle. And the hypotenuse would be C, right? So it's B over C. And then if we're looking at angle B, then the cosine of B would be the adjacent leg, which would be not C, because that's the hypotenuse. It wouldn't be B, that's the opposite leg. It'd be A. A is the adjacent leg over the hypotenuse C. And tangent is opposite over adjacent. Opposite over adjacent. So we're going to go ahead and work these out using a calculator. So sine of A of this triangle here, this right triangle, is, here's my angle A. The opposite leg would be this one, right? So it'd be equal to 5 over the hypotenuse. The hypotenuse is the side that is opposite the right angle, so it would be 13. And then we'll drop that into a calculator. So it's what, 5 divided by 13. And we're going to round it to the nearest hundredth place, which is that one there. So since the thousandths place is a 4, we're going to leave this as is, and it's going to be 0.38. So I'm going to say 0.38 and box it. Now cosine is a little bit different. It is adjacent over a hypotenuse. So here we have cosine of A. This is angle A. The adjacent leg would not be this one. This is the hypotenuse. So the adjacent leg would be 12. 12 over 13. Right. So we'll move over to our trusty calculator and do 12 over 13, so it's rounding to the nearest hundredth. So since this is a 3 in the thousandths, we're going to leave it as 0.92, so it's equal to 0.92. And then the tangent of A is opposite over adjacent. So here we're on A. Opposite would be 5, adjacent would be 12. So we'll do 5 over 12. So go over to our calculator. 5 divided by 12 is equal to, now we're rounding to the hundredths place. So since we have a 6 over here, and the thousandths place, we're going to round it up to 0.42. So 0.42, box that. And so that's how we do that. And then we're going to go ahead and use the inverse trigonometric ratios in order to find the actual angle measures. You can use a calculator and the sine, cosine, or tangent to find the measure of the angle, called the inverse of the trigonometric ratio. Inverse of the trigonometric ratio. So how does this work? Well, if we have sine A is equal to x, like we do over here, sine A is equal to 0.38. then what we can do to find the measure of angle A, this mysterious angle A, is we can drop in the inverse of sine. This is the inverse of sine x, and that will show us the measure of the angle. So if we do inverse of 0.38, that will give us the measure of the angle A. Okay. Now if we do the inverse of cosine x, that will also give us the measure of the angle, right? Or the inverse of tangent would also give us the measure of the angle. So why don't I prove that to you by running through these? So let's do inverse of the sine A. So we'll come over to our calculator. The inverse button is right here in Google, inverse, right? So do inverse of sine. Oh, I guess we need to put it down first. So let's do 0.38 inverse sine. No. Inverse sine. Hold on. Okay. Inverse sine of 0.38. And then here you're going to put radians or degrees on this part right here, radians or degrees. And we are familiar with degrees, right? So let's click in on degrees, or else you're going to get values that you're not familiar with. But arcsine is another way of saying inverse of sine of 0.38 is equal to 22.33. So here it's 22.33 degrees, right? Let's go ahead and try the cosine A of 0.92. Inverse cosine of 0.92 is 23. Oh, that should be the same actually. Oh, I guess it's because we haven't put in enough of the decimal places, right? So if we put in like 0.92, 4, 5, 8, 7, then we would have the same number of degrees. But more or less it's the same. It's 23 degrees, right? And then we're over here. This last one would be tangent of inverse tangent of 0.42. So we come over here, we go inverse tangent of 0.42, and that also gives us close to 23 degrees. Right? But if we put more decimal places here, we would have them all represent the same degrees in the angle. So anyhow, we're here. This problem is use the calculator to find the measure of angle T. All right, how do we find the measure of angle T? Well, we need to use one of these ratios, and then we can use the inverse to find the measure of the angles. Now, which one should we use, right? So if we use angle T, then what do we have? We have the opposite, and we also have the hypotenuse, right? If we're here at angle T, we have the opposite, and we have the hypotenuse. So if we come over to our ratios, what one has opposite and hypotenuse? That's sine. It's opposite over hypotenuse, right? So I'm going to go ahead and use sine for this one. So I'm going to say sine of t is equal to opposite over hypotenuse is 29 over 34. And what? Yeah, so now we're going to go ahead and drop it in the calculator. Round to the nearest hundredth place, so it's going to be 29. Whoa, 29 divided by 34 is 0.85. So it's going to equal to 0.85. Now to find the measure of angle T, we would need to do the inverse sine, right? So sine inverse of 0.85. And that will give us the degrees. So let's go back to our calculator, and we'll do the inverse sine of 0.85. Make sure we're on degrees and not radians. Classic mistake. We'll hit enter, and it's 52.2 degrees. So 58.2 degrees, like so. And we're done. So we're going to use those techniques to work out these problems here, and I'll go over the answers in the next video.